Welcome to SB Productions. Hi, my name is Sharon and today we'll be learning about the division of polynomials. Try factorizing this equation. X squared plus 8x plus 15 equals 0. If you cannot do this, you're watching the wrong video. Please watch our video on quadratic equations and factorization. This factorizes into x plus 3, x plus 5. Pause the video and try to factorize this equation. X cubed plus 6x squared plus 11x plus 6 equals 0. You can't do this using the same method. Instead, we must use synthetic division. The first step to factorize the polynomial is to find one of the factors, and to do this, we must use the factor theorem. The factor theorem states that if a polynomial p of x is divisible by x minus k, then p of k is equal to 0. If this didn't make any sense, don't worry, let's put this into context. Let's say our polynomial is p of x is equal to x cubed plus 9x squared plus 26x plus 24. If we wanted to check whether or not x plus 1 is a factor, we must try p of minus 1. We use p of minus 1 because you must use the opposite sign of the value. For example, if we were checking if x of minus 2 is a factor, then we would have used p of 2. Now, to try p of minus 1, we must substitute negative 1 into the polynomial. This will result in negative 1 cubed plus 9 times minus 1 squared plus 26 times negative 1 plus 24. This simplifies to 33 minus 27, which is equal to 6. Therefore, x plus 1 isn't a factor because there's a remainder, and 0 is not equal to 6. So, x cubed plus 9x squared plus 26x plus 24 isn't divisible by x plus 1. But how about x plus 2? Since we're trying x plus 2, this means we must use p of minus 2. Now, if we substitute minus 2 into the equation, it will equal minus 2 cubed plus 9 times minus 2 squared plus 26 times minus 2 plus 24. This simplifies into 60 minus 60, which equals 0. This means that x plus 2 is a factor. Now all we have to do is divide x cubed plus 9x squared plus 26x plus 24 by x plus 2. The easiest way to do this is using synthetic division. First, we place the minus 2 from the x plus 2 on the top left hand side of our division and put a square around it. Then we write our polynomial next to it, but we exclude the x's, only leaving the coefficients. Then we leave a line and draw a line. We must bring the first coefficient down and multiply it by the number in the box, in this case minus 2, and place it underneath the next coefficient, which is 9. Now we must add 9 plus negative 2, which gives us 7. And now we place a 7 next to the 1. Once this is done, we must just repeat the process, just multiplying the bottom number by minus 2 and placing it under the next coefficient. So now we must multiply the 7 by minus 2 to get minus 14 and place it under the 26. Then we must add 26 to negative 14, which gives us 12. Now we must multiply the 12 to minus 2, which gives us minus 24. Now all that's left to do is add the 24 to minus 24, which gives us 0. This means it is a factor. Just like we proved before, if it isn't 0, that means it isn't a factor. The numbers before the 0 are the coefficients for the next polynomial. Here it would read x squared plus 7x plus 12. Now that we have a second order polynomial, we can factorize this using the old method. So the final answer will be x plus 2, x plus 3, x plus 4. If the question asks you to find the remainder of a polynomial divided by a known factor, we must use the remainder theorem. The remainder theorem is like the factor theorem, but rather than getting 0, we'll get a remainder. For example, take p of x as x cubed plus minus 2x squared minus 5x plus 6. What is the remainder when divided by x plus 3? So, all we need to do is put negative 3 in the function and get the answer. P of negative 3 is equal to negative 3 cubed minus 2 times by negative 3 squared minus 5 times by minus 3 plus 6. This simplifies to minus 45 plus 21, which equals minus 24. So the remainder is minus 24. Thanks for watching. Please like, comment, and subscribe. If you have any questions, please write to us in the comments below. We are always there to help.